Until now, we have seen quite a few Terraform commands in action, such as the Terraform init, plan, and apply. Let us now take a look at some more commands available in Terraform. The first command we will take a look at is the Terraform validate command. Once we write our configuration file, it's not necessary to run Terraform plan or apply to check if the syntax used is correct. Instead, we can make use of the Terraform validate command like this. And if everything is correct with the file, we should see a successful validation message like this. If there's an error in the configuration file, the validate command will show you the line in the file that is causing the error with the hints to fix it. In this example, we have used an incorrect argument for the local file resource. It should be file permission and not file permissions. The next command that we are going to see is the Terraform fmt or the Terraform format command. This command scans the configuration files in the current working directory and formats the code into a canonical format. This is a useful command to improve the readability of the Terraform configuration file. When we run this command, the files that are changed in the configuration directory is displayed on the screen. The Terraform show command prints out the current state of the infrastructure as seen by Terraform. In this example, we have already created the local file resource, and when we run the show command, it displays the current state of the resource including all the attributes created by Terraform for that resource, such as the file name, file and directory permissions, content, and ID of the resource. Additionally, we can make use of the -JSON flag to print the contents in an JSON format. To see a list of all providers used in the configuration directory, use the Terraform providers command. You can also make use of the mirror subcommand to copy provider plugins needed for the current configuration to another directory, like this. This command will mirror the provider configuration in a new path /root/terraform/new_local_file. We saw how to use Terraform output variables in one of the previous lectures. If you want to print all output variables in the configuration directory, use the command Terraform output. You can also print the value of a specific variable by appending the name of the variable to the end of the output command, like this. The Terraform refresh command is used to sync Terraform with the real-world infrastructure. For example, if there are any changes made to a resource created by Terraform outside its control, such as a manual update, the Terraform refresh command will pick it up and update the state file. This reconciliation is useful to determine what action to take during the next apply. This command will not modify any infrastructure resource, but it will modify the state file. As we saw earlier, Terraform refresh is also run automatically by commands such as Terraform plan and Terraform apply. And this is done prior to Terraform generating an execution plan. This can, however, be bypassed by using the -refresh = false option with the commands. The Terraform graph command is used to create a visual representation of the dependencies in a Terraform configuration or an execution plan. In this example, the local file in our main.tf file has a dependency on the random pet resource. This command can be run as soon as you have the configuration file ready, even before you have initialized the configuration directory with Terraform init. Upon running the Terraform graph command, you should see an output like this. This text generated is hard to comprehend as it is, but it is a graph generated in a format called dot. To make more sense of this graph, we can pass it through a graph visualization software such as GraphViz. And we can install it in Ubuntu using apt, like this. Once installed, we can pass the output of the Terraform graph to the dot command, which we installed using the GraphViz package, and generate a graphic like this. We can now open this file via a browser and it should show a dependency graph like this. The root is the configuration directory where the configuration for this graph is located. We can see that there are two resources, the local file called pet and the random pet resource called myPet that makes use of the local and the random provider respectively. And finally, we can see that the local file called pet depends on the random pet resource called myPet, as we have used a reference expression in the local file resource that points to the ID of the random pet.